Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets, so that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides, and so that'll be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19. And we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include A, S, V, and U? That's got a T in it, that's got a T in it, so it's going to be this one here. So let's write that out. V squared equals U squared plus 2AS. So that would be 34 squared equals U squared, because that's the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals u squared. Then we're just going to square root both sides. And so square root of that is going to be 25.8 729 blah blah blah, and it says it wants it to 2 decimal places, so it's going to be 25.73. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the 2 parallel sides here. Just pick a different colour. Here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14, therefore the radius would be half of that, which is 7, and the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in 2s. So this will be 28. So the x coordinate will be 28. And this will be 19. So our coordinate will be 28, 19 for our outlier. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chiltern, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chiltern to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chiltern at 9 o'clock. He drives from Chiltern to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this the whole thing needs to be 45 minutes, or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time. And we're covering up the time, because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30. And we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the ft, which is just the frequency times the duration of calls. Now in this first group we're not timesing it by 80 to 85 or anything like that, we're timesing it by the midpoint. So our midpoint effectively becomes the t. So we're going to do 15 times that, which will be 1237.5, and we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. So let's just write out this sequence. So first thing we're going to do is work out what the sequence is going up in. And we can see here that we're adding 15 each time in our sequence. And whatever the sequence is going up in is what goes before n, so it's going to be 15n. Now 15n would give us the 15 times table, and this isn't the 15 times table. So to work out what the offset is, we go and find our 0th term. So instead of adding 15, when we go backwards, we're going to take away 15. And so that would be 10. And so our answer is going to be 15n, and we're going to add that 10 on. So we're given 21 to 4 is the ratio. And we're just going to have our lines in, because what we need to do is make the left-hand side be 1. Okay. And to do that, for 21, I need to divide it by itself, divide it by 21. And we're going to do the same to the right-hand side. So 21 divided by 21 is 1. Perfect, that's what we wanted. 4 divided by 21 is 0.190, blah, blah, blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. So I'm going to start off just with a quick sketch. And we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here. And let's just draw a line between them. And let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here. And we know that this angle here will also be 85 degrees. Because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles. And we know that this angle here is going to be 180 degrees, because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an x and this a y and written x equals 85 and y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid. And we're going to do x minus 15 at the top, x minus 15 at the bottom. Then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x. Same again here. And then we've got a minus times a minus, which is a positive 225. Put all the terms together. Now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. So we're looking for angle DEC, which is this one here, but we can't go directly there. We've got to kind of work our way towards it. And the first thing I'm going to look at is these set of parallel lines here. And we've got a line going through these parallel lines, which is this line. If I try and do it without removing it, this line here. And so therefore this angle here and this angle are going to be corresponding. So this is going to be 69 degrees. So I need to write that down properly. So angle CDE equals 69 degrees because of corresponding angles. Okay. So if I know that the CDE is 69, I also will know that this angle here is 69 because they're the bottom two angles in a triangle. Now, when I say that, I mean when an isosceles triangle is the right way up, the bottom two angles are equal. So they're the bottom two angles in an isosceles, although the isosceles is on its side here. And we need to write that down, so it would be angle DCE equals 69 degrees. And this time it's because it's an isosceles triangle. And finally, we can work out what CED is by taking those away from 180. So angle CED, or actually I should keep it as it says in the question, DEC, is equal to 180, take away the 69 plus 69. And the reason for that is angles in a triangle equal 180 degrees. And when you do that, you get the answer of 42 degrees. So the answer is 42 degrees. The volume of any prism is found by working out the area of the cross-section and timesing it by the length. So we're given the cross-section here is 92, and the length is basically how 3D the prism is, so that's going to be times 4, so that's going to be 368, so 368 centimeters cubed. The first thing to notice is that the tree must be closer to CD than AB. So if we draw a line across the middle, it can't be in the top bit because that would be closer to line AB. The second piece of information that is given to us is it must be at least 11 meters away from point C. So we get our compass out and measure 11 centimeters, or whatever the scale we're using in this diagram is, and we draw a quarter circle from C. And it says shade the region that it can be planted. So this is the region that represents closer to line CD than AB, but also not within 11 meters of point C. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half A plus B times H, and A and B are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula, so it'd be half A plus B H, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount, so we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. What is it? 990. Now, when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,070. 0, 5. And that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So the angle of elevation is when you are looking horizontally, like here. It's the angle that you have to look up to see something, so that castle. So this is the angle of elevation here, which I'm just going to call x. And we've got a right angle triangle here where we have two lengths and we're looking for an angle, so we're going to be using trigonometry. So we're just going to label this up. So we've got the opposite here, adjacent to here. We don't need the hypotenuse at all, so get rid of that. Let's just put our SOHCAHTOA in. So we've crossed out the hypotenuse, so it won't be sine or cos, it will be tan. So it will be tan x is equal to the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan of both sides. And so the inverse tan of 49 over 98 is 26.565, etc. And it says it wanted the nearest whole number, so that will be 27 degrees. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start, and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can divide top and bottom by 3. And that would be 16 over 75. So either 48 over 225 or 16 over 75. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, Now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves, so we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, so that will be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8, and 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA, and so we're doing tan X equals the opposite, which is 49 over 98. Get our lines in, and we're going to do the inverse tan to both sides. So we get X equals, and we do inverse tan, which is 26.565, blah blah blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labeling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent. So we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two. So it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in. And we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29. And we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that in the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79. And that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. So here we're just adding the column vectors. So we're going to add the tops, so 2 plus the 5, and we're going to add the bottoms, minus 4 plus 6. 2 plus 5 is 7, minus 4 plus 6 is 2. So our answer will be 7, 2. We know that column vectors are shown with the amount right we go at the top and the amount up we go at the bottom. So we've got to work out how far right and how far up we go. So we're going to count the jumps from the start, which is at A. So 1, 2, 3, 4, 5 jumps right. So the top of our column vector is going to be 5. And 1, 2, 3 down. Now, because it's down, it's going to be minus. and we've got 3 down. So it's 5 at the top and minus 3 at the bottom. First thing we need to do is find out what 10% of the 109 is. So we're just going to multiply by 0.1, and that gives us 10.9. So what we're going to do is we're going to add and subtract this from 109. So we're going to do 109 take away 10.9, which gives us 98.1. And then we're going to do 109 plus 10.9, which will give us 119.9. So our error interval is between 98.1, and it says to use t, and 119.9. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed, and all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'll be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now, so it's y equals 3,430 over x cubed, and that actually is our answer. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that. And so this is going to be 44 degrees here. So angle BFD equals 44 degrees. And the reason you need to give is the alternate segment theorem. And you have to use those words, otherwise you won't get the marks. Now, next I notice that we've got a set of parallel lines here, and we've got a line going through them, and so the 44 degrees there is going to be equal to this one here, and so this is going to be 44 degrees. So we say angle FDE equals 44 degrees. And the reason this time is alternate angles, we'll put the E in, angles. And again, you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here, and here. And the bottom 2 angles in isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here. So angle EFD is also 44 degrees. And again, we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here, and it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44, and the reason is angles in a triangle add up to 180 degrees. And so 180 take away the 44 plus the 44 is 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all four corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle, what's it called in the question, angle FBD is going to equal 180 take away 92. And again, we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realising is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360 take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360 take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should re-put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. So we're going to need to complete the square to be able to answer this question, but the first thing I need to focus on is this 2, the coefficient of the x squared. I want to make sure that x squared doesn't have a coefficient, or has a coefficient of 1. So we're going to start off by just removing or dividing out that 2. And we're going to do it from the x squared and the x term. So I'm going to be left with the x squared plus, and that's 14x. And we just leave this plus 5 at the end. That plus 5 really only ever comes into use at the end. Now we're going to complete the square here. So that will give us brackets x plus half of the x coefficient, which is 7 squared. And I'm just going to expand that quickly here. So x plus 7 squared is the same as x plus 7, x plus 7. And when we expand that, we get x squared plus 14x, which is good. And then we get plus 49. Now this bit here is the bit we need to remove. So what I'm going to do here is just take away that 49, because we don't really want that 49. Close bracket, plus 5. Okay, now I'm going to expand these brackets and have the 2 next to the x plus 7 squared. And 2 times minus 49, which will be minus 98, plus 5. And then all we need to do now is add the minus 98 and the plus 5 together, which should be minus 93. The m part will be the 2, the p part will be the 7, and the q part will be the minus 93. So here we have a cube and we're asked to find length BH. Now there is a simple formula for us to be able to do this, but we're going to pretend we don't know that formula, and then maybe we'll talk about it at the end. So we're going to split this up into 2-dimensional triangles. I'm going to start with a triangle down here. Let's just draw that triangle in. And we've got 3 at the bottom. Now we actually have 3 down this side because it's a cube, so all lengths are exactly the same. And we're looking for length FH. We know we're going to use Pythagoras for it because we've got a right angle triangle and we've got 2 sides and we're looking for the third side. So that's going to be EH squared plus EF squared. Let's get our tram lines in. So that's going to be 3 squared plus 3 squared, which is 9 plus 9, which is 18. Square root both sides, find out what FH is, which is going to be 4.242 recurring. We could have left it as square root 18. Okay, next thing we're going to do is we're going to create another triangle. We're looking for BH, so we're looking for this one here. So we're going to create a triangle like so. And let's draw it in as a 2-dimensional triangle. Now again, it's a cube, so this length here is going to be 3. We've just found the bottom one, which is 4.242, blah, blah, blah. I'm going to keep it into my calculator so I can have some precision. And we're looking for BH, which is this one here. So we're going to be using Pythagoras again. Why not? Okay, get my tramlines in. Okie dokie, so let's put FH in, which is that 4.242 blah 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 squared. BF is just 3, and that will give us exactly 27. And then we're going to square root it, and so we've got BH equals 5.196 blah blah blah, and it says it wants its 2 decimal places, so it's going to be 5.2. Now really, because it says 2 decimal places, we should write the 0 as well, even though obviously 5.20 is just the same as 5.2. But if it asks for 2 decimal places, we'll keep it to we'll always keep it to 2 decimal places. Now there is a formula that we can try out, and that formula says that when you've got this situation where you're looking for the diagonal of a cube or a cuboid, you can square all of the sides. And it's kind of like a mega Pythagoras. So if I get my calculator now and type in square root of 3 squared plus 3 squared plus 3 squared, and then press equals, I get exactly the same answer. So this formula here is actually quite useful, and if it's something you want to look into just to save a bit of effort with this question, feel free. But you do need to know the triangle method for when using trigonometry later on, and for kind of advanced questions on 3-dimensional right angle triangles. So you just need to make sure you know both methods, but if you want to use that quick shortcut method, feel free. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top, then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4 and the height is 5, and the radius for the larger cone is 20 and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975 blah blah blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775 blah blah blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775, and all those I'm going to keep in the calculator to keep the accuracy, and that gives us 10,388.199 blah blah blah, and to 2 decimal places it's going to be 10,388.20. Okay, so we're going to start by creating a cuboid, just so we can kind of visualize what's going on a little bit easier. And so the lengths on the cuboid, it says, are 14, 10 and 8. Doesn't matter which way around. Now the longest part of the cuboid will be the diagonal across it. So if I just show a diagonal there, and it doesn't really matter which one we pick. Ooh. I could pick this one here, go diagonal like that. They're all the same length, all the diagonals across. So the rod will be, if it's the maximum length of the rod, it will be along this diagonal. So we can first of all have to work out what this length here will be. and then we can use the fact that this is 8 here and work out what the length of the diagonal is. So I'm going to call this x, and I'm going to call the diagonal y, just so we've got something to refer to in our working out. And it might be helpful that this side here is 10. So we've got a right angle triangle, because this is right angled here, and we're looking for the value of x. So we know that we're going to be using Pythagoras, because we've got 2 lengths and we're looking for a third length. So it's a squared plus b squared equals c squared. So it would be 10 squared plus 14 squared equals c squared. And it's actually not c, we've called it x, so why don't I stay consistent, equals x squared. So I'm going to do 100 plus 196, which would be 296 equals x squared. And get our lines in. Should be quite easy because we just need to square root both sides. So I'm just going to square root that, and we get an answer of 17.20 blah blah blah. Now I'm going to keep that value in the calculator itself, because I'm going to use that to find out what y is, our diagonal. So the next thing we're going to do is, we know what this is, and this creates a right angle triangle here, and so we're just going to do exactly the same thing again. A squared plus b squared equals c squared. Our a is 8, so 8 squared plus, and then we've got 17.20 blah 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 squared equals, and then we're looking for y, so y squared. Now if I square the value that's in my calculator from before, the 17.20, and if I just click square it, it will put it back to 296, because I've square rooted it and then I'm just squaring it again. So it would be 64 plus 296 equals y squared. So I'm just going to add them together, which will be 360. And again, I'm just going to put my solving lines in. Not too difficult to solve this. Make it a bit nicer, because I'm just going to square root both sides. So I'm going to square root this, and it gives me the answer of 18.9736 blah 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 equals y. Now it says it wants the answer to 2 decimal places, so it would be 18.97 to 2 decimal places. Now a different way we could have done this is we could have worked out y straight away by working out the, like, I don't know what to call them. I'm gonna label them A, B, and C. So A, B, and C. And what you can do is you can do the y squared equals a squared plus b squared plus c squared. It's basically the width squared plus the length squared plus the height squared. And so we would have had 14 squared plus 10 squared plus 8 squared. And when you've done that, you would have got 360. And this would be y squared equals. And then when I put the solving lines in, I would have done the same thing, square rooted both sides, and you obviously would get the 18.973 blah 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 again, and then you would have written down the answer. So there's 2 different ways of doing that. Obviously this way is a lot quicker, but you have to just remember that if you've got 3 lengths on the cuboid and you'll ask for the diagonal, then this formula here can be a much quicker way of finding the answer. A simple trick when you're finding the inverse of a function is to replace or to switch the y and the x. Now we don't actually have a y in here, but we can just put one in, it's not a problem. So we can just rewrite this function as y equals x over 10 minus 11, and we're just going to switch around the y and the x. So x equals y over 10 minus 11. Now the objective now is to get the y on its own, to make y the subject. So we're going to first of all add the 11 both sides, And I've made an amateur move here. I've not left myself enough room, so let's just scoot that across. Okay, so add the 11, so it would be x plus 11 equals y over 10. Next thing we're going to do is multiply by the 10 to get y on its own. So it would be 10 brackets x plus 11 equals y. Expand those would be 10x plus 110 equals y. Now this doesn't equal y. We are looking for the inverse function with this notation here. So we just replace the y with this notation and we get 10x plus 110. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.